Welcome to Chemistry Made Simple. Once again, we are going to begin with another tutorial. Today we are going to look at volumetric analysis, part 2. Today we are also going to talk about a specific thing altogether. It is still the continuation of the part 1. So let me remind you a little bit of what we studied in the part 1. In the part 1, we spoke about analysis, the concept. Then we also spoke about the experimental procedure that will help us do analysis under that concept. We realized that we have two: gravimetric, volumetric. So it is volumetric analysis we have picked. Under volumetric analysis, under the note, I said something. I said there is an aspect we call titration. So for us to achieve the purpose of volumetric analysis, we have to go through a process we call titration. Therefore, today, as you have joined me, we are going to study titration as a whole today. Join me to the board to know the definition for titration. Titration, what is it? Titration, the act of adding measurable amount of a solution of one reagent from a burette to a definite amount of another reagent of known concentration until the reaction between them is complete. So we are going to look at an act, which is also a process, where we are going to add measurable amounts of solutions from one reagent to be placed in a burette, and then the other one in a conical flask. Now we are going to titrate until the reactions between them is fully and then complete. In that case, note, the solution whose volume is to be determined is always put into the burette and is run against the solution with known volume in the conical flask. So this is what you are supposed to know. The solution that we are supposed to determine its volume is always placed in the burette. I will introduce you to the burette. I know you may have been introduced to, but I'll still introduce you to it. So that form of solution is always placed in the burette so that we can determine the volume. And then the volume, which is a fixed volume, which is always also delivered into the conical flask, is a solution which is also standard or standardized. Now, let's look at the types of titration, because we know that we have different forms of solutions. Therefore, we are supposed to also know the type of titration. Now, 1, acid-base titration. So we have acid-base titration when the reacting solutions are acid and then base. So when the reacting solutions are acid and then and a base, then we term that as acid-base titration, because it is acid-base reaction that will take place over there. Note, the end point of any acid-base titration is aided by an indicator. In fact, in our previous tutorial, I introduced you to indicator. In fact, we did not do anything about that. We just wanted to know the actual composition, the nature of the solution we are dealing with. Therefore, I first introduce you to indicator. We will deal with indicator the more. today in our discussion. Therefore, let's look at the second aspect of titration. Redox titration. So we also have redox titration as our second form of titration. When the reaction is between oxidizing agents and reducing agents. So when the reaction is between oxidizing agent and the reducing agent, then we undergo what? Redox titration. Therefore, it is very good because you have already mentioned endpoint. What is it? What is endpoint? Endpoint. It is the point where equivalent amount of the two solutions have completely what? Reacted. So it is the point where equivalent amount of the two solutions have completely reacted. That is what? Endpoint. Now, there is something that we are supposed to note. In acid-base titration, it is where equivalent amount of acid and base have completely reacted according to the reaction equation, resulting in change in the color of the indicator used from the first observational color when it was dropped in the solution in the conical flask. So, specifically, I have described endpoint specifically under a certain condition. The condition is that if it is acid-base titration, then what are we expecting? We said we expect equivalent amount of the acid and the base to have undergone complete what? Reaction. The complete reaction must be according to the reaction equation, resulting in change in the color of the indicator used from the first observational color when it was dropped in the solution in the conical flask. Now we have the idea about indicator changing color. Said I will introduce you to it once again. Now let's look at titre. So when you say the titre, what does it mean? It is the volume of solution from the burette at endpoint. So the volume of solution from the burette, or which is run from the burette at endpoint, is what we term as what? The titre. So mostly you will see 3 titre. So 3 running from the burette. When you say 3 titre values, you will see 3 running. The first running, second running of the burette, and then the third running of the burette. Note, the values to be recorded from the calibration of the burette for which the meniscus of the solution reach is referred to as titre value or titre values. So we will be recording certain values from the calibrations of the burette, but it will only be recorded when you read the solution from the meniscus. That is when you pick your value. So you don't just read any value, but you read the value just under the meniscus or where the meniscus was curved. Now, average titre. When we say average, we mean the mean of certain values. It can be discrete. So the mean of certain values. So it is the mean of 2 or more consistent titre values. We have already explained that the titre values will be recorded in a specific way, of which I've already explained. When you have those values, there you find the average of those values. But this is how we find the average of those values. We said it is the mean of 2 or more consistent titre values. So it means there is a possibility that you may have 2 of the values being consistent. I will explain the consistency. And then you can also have 3 of the values being consistent. When you reach the part 3, you'll understand what I'm talking about, or you'll know what I'm talking about. Now note, the consistency difference should lie between plus or minus 0.1 or plus or minus 0.2. That is where the consistency values must lie. Above that, in fact, you are out of range. Therefore, you should note that. Now, let's look at another point. What is a titrant? What is a titrant? In titration, the solution whose concentration is known is referred to as the titrant or a titrant. So the solution whose concentration is known in titration is referred to as the titrant. Note, always a fixed volume of that solution is pipetted and delivered into the conical flask. So always, this is what happens. A fixed volume of that content is pipetted and delivered into the conical flask, which is referred to as aliquot. So the portion in the conical flask which has been pipetted, the fixed volume which has been pipetted into the conical flask, that solution or that portion over there is called the aliquot. Therefore, we are moving ahead to what I've already said, what I've already mentioned, an indicator. An indicator. What is it? What at all is an indicator? Now, you can pause the video and then begin to guess. Think about it. If you are guessing and then nothing is coming out, don't worry, you will deal with it. What is an indicator? Before we move to the definition of an indicator, we want to know the items you'll be dealing with. So let me just introduce you to certain materials, apparatus that we'll be dealing with, or that we'll be using for today. Or let me introduce you to the material that we'll be using for mostly in our titration. We have the indicators, phenolphthalein, the common ones, and then methyl orange. We have the conical flask or the Lemaille's flask. We have the wash bottle. And so that is the wash bottle. Now we have the burette. So that is the burette. You see, it has a calibration. So it has been calibrated nicely. Now we also have the 25 centimeter cube pipette, and then the flip, as I introduced to you previously. So the flip is also there. And then we also have a dropping pipette, which will be used to pick some few centimeter cube of the indicator. Now we also have the filter funnel, which you can see one there. So the burette, if you look at the nature of the burette, it is narrow, and then it has a tube with a teat. And then here we have a tap. So you can see the tap over there for regulation of the solution. So these are the few material that we'll be dealing with. And then we also have the reagent bottles. So this is solution A, hydrochloric acid. I've already indicated it because we have already described that. Now we also have solution B, which is sodium hydroxide. We have a lot of solutions, but we'll be dealing with this one for the meantime. Now let's move to acid base indicator or indicator. What does it mean? So what is an acid-base indicator? It is a weak acid or base which produces a particular color in a solution of different pH. So that is a definition for acid-base indicator. Or so it is a weak organic dye which changes color depending on the pH of the medium to which it is added. So that is also another definition for an indicator. Now here I just want to make some few changes over here or add some things more. So you can see a weak organic acid or base. So for the first one, I can say a weak organic acid or base which produces a particular color in a solution of different pH, or it is a weak organic dye which changes color depending on the pH of the medium to which it is added. Any of these definitions is deemed correct. So we have known an indicator. Students, we are going to do something specifically over here. We want to know the indicators and then the color that will be produced. So we want to know the indicators and then the color that will be produced in a specific solution. Specifically, we are going to look at acid solution or acidic solution, and then alkaline solution, basic solution or basic solution. And then the few indicators that we are going to deal with will be phenolphthalein and then methyl orange. And then we also look at litmus for the sake of the commonest, how common they are. For that matter, I would like to introduce our madam who has been helping us in this laboratory. She is in the person of Madam Abna Prempe Jennifer. She will be helping us to go through the practical test as she has already been doing. So she's going to help us with the practical test. So that is our madam. And then we will go through it quickly and then we'll look at the table for that. I said we are going to look at 3 indicators. The third indicator, we don't have it here. Yet, I'll produce the colors for you. Don't worry, I'll produce the colors for you. And then we can also go through some small form of test for that. So don't worry, we will do that. Now, for the first form of practical test, madam, are you ready? So we have the 2 indicators, as you have seen. The 2 indicators are there. Okay, now we have the solution which has already been pipetted. So with the aid of the pipette, she has already pipetted the form of solutions that we require. Good. So which solution are you going to begin with, madam? Solution A. She said we are going to begin with solution A. Good. So solution A, that is acidic solution, HCl. So quickly, we are going to look at some common indicators and then the colors or their colors that will be produced. So some common indicators. we are going to look at some common indicators and their color in acidic, basic, and neutral medium. That is what you are going to deal with for today. Now, let me clear our workspace so that you have enough workspace. So, madam, let's begin. Take us through. I'm so eager to know what will happen. Madam, will you tell us which indicator you are using?
Methyl orange.
So, methyl orange. In which solution? Solution A.
2 drops.
Okay, 2 drops. This way. Okay, so you can use your white eye. So we have methyl orange in solution A, which is acidic. And methyl orange produces a red color in acidic solution. So quickly, let's draw a table for that. So I'm going to draw a table. So indicator, methyl orange. So methyl orange is red in acid. Okay, madam, let's continue with the next one. You want to look at phenolphthalein in solution A. Okay. Some few drops. In solution A, good. So we can use the white towel. Good. So we have seen the color produced. You can guess what color this is. It's colorless. We have already discussed that. So it is colorless. Good. So phenolphthalein is colorless. So phenolphthalein is colorless in acidic what? Medium. Now let's look at solution B and then look at the methyl orange. Okay, 2 drops. She said it earlier that she'll be using 2 drops. Okay, so you can guess what color this is. If your guess is that the color is yellow, then you are correct. So methyl orange produced yellow color in there. So in a basic medium, it is yellow. Let's take the phenolphthalein. Okay, let's look at the phenolphthalein. 1, 2 drops. Wow, we have deep pink, or you can say pink color produced. Pink color. Now, the next thing we are going to look at, I said for that solution we don't have, that is litmus. Litmus solution. For that one we don't have litmus. So for litmus, it's red, blue, and then in neutral is purple. It's purple. So it's to produce a purple solution. For what we have, we are also going to practice. So for neutral solution, it will be very difficult for us to say we want to add some few drops of hydrochloric acid and then sodium hydroxide and then for them to react in that manner. Therefore, you can have a very common or universal solvent which we can use for our test, which is a neutral solution, that is water. quickly, let me fetch water. So that is tap water. Another tap water. Now we are going to look at the color. We want a neutral solution, so that is a neutral solution. Methyl orange. First, we want to test for methyl orange in a neutral solution. 2 drops. Okay. Wow. You can guess what color this is. If your guess is that it is orange, then you are correct. So in a neutral solution, you can see the top of the surface of the solution that has produced an orange color. So that will be orange on the board. Now let's also look at phenolphthalein. Phenolphthalein will confirm that this is truly orange. Okay, doesn't matter how much you add. So it is still producing a colorless form. It's reacting with the water molecules. So it's colorless. So colorless. In summary, that is the summary of the table. Methyl orange in an acid produces red color. In a basic medium produces yellow. In a neutral medium produces orange. Phenolphthalein in an acidic medium produces colorless. Phenolphthalein in a basic medium produces pink. Phenolphthalein in a neutral solution produces what? A colorless form. Now, litmus solution. I told you we don't have that one, but we can still look at the colors that will be produced. Litmus in acidic solution produce what? Red. Litmus in a basic medium also produce what? Blue. And then litmus in a neutral solution produce what? Purple. So we have red, blue, and then purple color being produced at the end. Now, we are going to look at these various indicators, their nature in the forms of titrations that will be performed under acid-base titration. Now, we are going to look at forms of acid-base titration and then the colors that will be produced. That will bring us to the end of our story today. Now, we are going to look at the table, a very simple table. But I said we are going to look at forms of acid-base titration. And then we also look at the color of the indicator in this form of titration. So I will tell you the initial color, then the color that will be produced at the end, and then the nature of the solution that results into that form of color. Now we are going to look at forms of acid-base titration. Nature of solution at endpoint. indicator. That is appropriate indicator for that. And then let's do that. Our first observational color of indicator. So we have forms of acid-base titration, nature of the solution at endpoint, appropriate indicator, and then form first observational color of indicator. And the last thing we will look at is the color produced at endpoint. So color of indicator at end. So color of indicator at endpoint. At endpoint we produce a different color. So that is the theory behind it. So this is the theory. We are going to examine the theory for today. Now, forms of acid-base titration. Strong acid against strong base is a form of acid-base titration. And then the appropriate indicator that can be used, methyl orange. Methyl orange is appropriate for that. At endpoint, what will be the nature of the solution in theory? Neutral. The solution will be neutral at endpoint. Now let's look at our first observational color, that is in the alicot. The solution that will be pipetted, the standard solution that will be pipetted and then be delivered into the conical flask is what we term as the alicot. So what is the nature? That is the base. The base will be pipetted. So the methyl orange in the basic medium, we have already deduced that it's what is yellow. From theory, it's yellow. At endpoint, because it is a neutral solution, it will produce an orange color. You see how nicely this table 1 answers table 2. So it will be a neutral solution. Now let's look at strong acid against strong base. Strong acid against strong base. Once again, the appropriate indicator will be phenolphthalein. The first observational color, we will still pipette the base, so it will be yellow. At endpoint, the solution will be neutral. At endpoint, the solution will be what? Neutral. Now, let's look at phenolphthalein in a neutral solution. Is what? Colorless. Phenolphthalein in a neutral solution is colorless, as we described there. Now, let's look at another form. Strong acid against weak base. Strong acid against weak base. the solution will be acidic, and therefore our choice of indicator will be methyl orange. The color of methyl orange in that weak base will be yellow. At the end, our solution will be acidic. At end point, if the solution is acidic, then methyl orange will produce a red color. Not pink, a red color. Now, strong base against weak acid. Strong base against weak acid. The choice of our indicator will be phenolphthalein. Phenolphthalein. The first observational color of the indicator in a strong base will be that is phenolphthalein in a strong base. So phenolphthalein in the base is pink. Phenolphthalein in the base is what? Is pink. Therefore, what will be the color at end point? The color at end point will depend on the nature of the solution. So the nature of solution at end point, strong base and then against weak acid, the solution will be basic. And if the solution is basic, from the color of neutral, the color of phenolphthalein in the basic solution will still be what? Pink. I will explain this one for you to understand. Now let's look at something over here. Strong acid against strong base. The phenolphthalein, the color, let me make some changes over there. Phenolphthalein in the basic, in fact, we are going to drop some few centimeter cube of the phenolphthalein in the strong base, and it will be pink. Sorry for that. It is pink, and then it will move to what? Colorless, because the solution will be neutral. Now we have strong acid against what? Weak. Strong base against weak acid. And then we said the solution, that will be pipetted, will be the base. If it is the base, and the phenolphthalein in the base will be pink. And then, because the solution at end point will be basic, it will still be what? Pink. Let me explain this one to you very well. Now, phenolphthalein, the first observational color of the phenolphthalein in the basic medium will be deep pink. The first observational color will be deep pink. It will be observed at end point where the solution is still basic, because phenolphthalein works in the basic medium. Phenolphthalein itself has a pH which ranges from 8.3 to 10. So it will function very well in a basic medium. So in a basic medium, I told you that the first observational color in a strong base will be what? Will be deep pink. And then when you titrate at end point, the solution will still be basic. If it is basic, then the color at end point will still be what? Pink. But here it will be faint pink, light pink, almost approaching colorless. But my dear students, it will not be a colorless form of solution. No. We said the theory behind the forms of titration is that at endpoint the nature of the solution will be basic. If it will be basic, then you will agree with me that phenolphthalein in the basic medium is pink. But the pink we are talking about, we said from the first observational color that the pink color is deep. So which means it will be reduced. The pink color will be reduced to a light or faint pink because of the volume of the acid will be running against that of the base. So technically, that is what happens. So the first table 1 answers table 2. I'm going to take you through table 2 again. The forms of acid-base titration. 1. We have strong acid against strong base. And I said the choice of the indicator, or the appropriate indicator that will help us within this form of medium is methyl orange. And methyl orange, the first observational color in the conical flask, which is in the solution, that is referred to as the aliquot, will be yellow because it's the basic solution that will be pipetted. So it will be yellow. Now at endpoint, the solution will be neutral, and therefore when you study neutral solution and then the colors that will be formed by methyl orange in the neutral solution, it will be what? It will be orange. Therefore, orange color will be used at endpoint. Now, strong acid against strong base. You also have the choice of indicator again. Phenolphthalein can be used. Now, phenolphthalein will be added in few drops to the solution in the conical flask, which is basic in nature. So it will produce a pink color. That will be the first observational color. Now at endpoint, you agree with me that the solution will be neutral. If it will be neutral, then at endpoint, let's look at the color of phenolphthalein in a neutral solution. It's colorless. So therefore it produces what? A colorless form of solution. Now let's look at strong acid against weak base. Strong acid against weak base, the choice of indicator that would be appropriate will be what? Methyl orange. Why? At the end, the solution will be acidic in nature. But remember that our first observational color of methyl orange in the basic medium, which is in the conical flask, will be yellow. And therefore, it will run to a red because the solution will be acidic in nature. And you agree with me that methyl orange in an acidic medium is what? Is red. Now, let's look at strong base against weak acid. At the end, you agree with me that the nature of solution will be what? Will be basic. And I told you already, or I've told you already that the phenolphthalein works very well in what? In the basic medium. And remember, we are going to pipette 25 cm cube of the base. The nature of color produced by phenolphthalein in a basic medium is pink. Here it will be deep pink. I want to still emphasize on that. It will be deep pink. And if it is deep pink, the color will reduce. So it will be faint. It will give us what? A faint pink color. So let me indicate over here. Deep pink to faint pink. That is the color change that will come. Now, in fact, if you run any few drop, a single drop, this color will change to what? To a colorless form. And of which, when you get to that point, you have passed end point. Let me give you note. The pH of phenolphthalein and then the pH of methyl orange, so that you know where it works best and then appropriate. So methyl orange, pH 3.4 to 4.0. So that is the pH of methyl orange. Phenolphthalein, pH 8 say 8.3 to 10. So that is the pH of the various. So you realize that, or you will now agree with me that phenolphthalein is basic in nature, and then that of methyl range is what? Acidic in nature. Therefore, methyl range works best, well, or appropriate what? In acidic what? Medium. So this one will be appropriate. Appropriate in acidic medium. And then appropriate in basic medium. Today, we have looked at the meaning of titration and then types of titration. You've realized that we have acid-base titration, redox titration, and then we have also looked at the endpoint. We have also looked at titre value, titre, average titre, titrant, and then also we have looked at indicators, basically acid-base indicators. We have looked at the various definitions for acid-base indicators, and then we have also looked at the table that was designed for the acid-base indicators nicely. So we have table 1 and then table 2. Today we have come to the end of our tutorial. See you in my next tutorial, where we will discuss a lot more about this, and then even how to add them, do this, look at the color change, and then the rest, and then go through the act of the titration itself. See you in my next tutorial. Thank you, and then